In section 6.2, we're going to look at one of our techniques of integration called U-Substitution. And U-Substitution is really the only technique you really need for the AP exam. We're going to learn other integration techniques in the Integral Calculus 30 course, but they won't be covered on the AP exam. So let's take a look at an example. Say you were asked to find the antiderivative of the following. Well, right now you could expand this by multiplying 3x plus 5 by itself 3 times, and then we could take the derivative of each term, but that would take a great deal of time. So we're going to use a technique called U-Substitution. What I'm going to do is I'm going to let this inside part here be u. So I'm going to let u equal 3x plus 5. So now I'm going to take the derivative of u with respect to x, and that derivative is going to be actually 3. I'm just taking the derivative of 3x plus 5. Now I'm going to move the dx up to the other side, and I get du is equaling 3dx. So now I'm going to make a substitution back to my original question. And in place of 3x plus 5, I'm going to put in a u. And I need to get rid of this dx, so I have to get dx by itself. And if I look down here, to get dx by itself, I have to divide by 3. So now in place of dx, I'm going to put 1/3 du. So this integral now is going to become the integral. Well, in place of 3x plus 5, I'm putting u, and it's still to the power of 3. And in place of dx, I'm putting in 1/3 du. Now, because 1/3 is a constant, my rules for integration allow me to put him out front. Oops. Should be a 3. So now I have this in a form that I can integrate. So this is going to be, that's a 3, so I integrate. I add 1 to the exponent and divide, plus a constant. So if I multiply the 1/3, I'm going to get 1 over 12 u to the 4th plus a constant. Now some people might be saying, why am I not distributing the 1/3 to a constant? Because a constant times a constant is still a constant. And now I'm going to resubstitute back in my original substitution for u. So this is going to equal 1/12. In place of u, I'm putting 3x plus 5 to the 4th power plus a constant, and that would be my final answer. Again, if I took the derivative of this, I'm going to get exactly back what I started with, and I'll show you. If I took the derivative of this, the 4 would come out front, so that would become 1/3. 3x plus 5 to the 3rd times the derivative of the inside is 3. The derivative of a constant is 0, so this is going to cancel out with this, and now I'm right back to what I started with. Okay, so in this next example, we want to use U-Substitution again, so I'm going to let u equal the part under the root sign, and therefore du, but instead of writing du dx, I am always going to move the dx up to the right-hand side, so the derivative of 4x minus 1 is 4. I'm just going to put the dx there. Okay, so now we can make our substitution. So in place of the 4x minus 1, that's going to become root u. And to get dx by itself, I'm going to have to divide both sides by 4. So I'm going to put the 1/4 right out front, and that would be 1/4 du. So now to integrate this, I'm going to change this to u to the 1/2 du. And now I'm ready to integrate, so 1/4 is my constant. If I integrate this, I add 1, which is going to give me 3/2. Dividing by 3/2 is like timesing by 2/3, and I times it by a constant. Multiplying these together, I'm going to get 2 over 12, which is really 1 over 6. U to the 3/2 plus a constant. And now I'm just going to substitute back in my value u. And that should be my final answer. Okay, in the next example, we have a product of 2 terms within an integral. So again, if you notice, this guy here is a 2x cubed minus 1, and the derivative of an x cubed is x squared, so it would make sense to let u equal the 2x cubed minus 1. And the 2x cubed minus 1 is also inside a bracket raised to a power of 5, so that's another indication of you're probably going to let u equal the stuff inside the brackets. So du is going to be 6x squared dx. And notice I have an x squared dx, so I have to divide both sides by 6. So now I can make my substitution. So in place of 2x cubed minus 1, I'm putting u to the 5th. In place of x squared dx, I'm putting in a 1/6 du. And now it's a very simple integral. U to the 5th becomes u to the 6 over 6 plus a constant, which is going to be 1 over 36 u to the 6th plus a constant, which is going to be 1 over 36. And in place of u, 2x cubed minus 1 to the 6th plus a constant. Okay, our next example, again, I'm going to let u be this part. So I'm letting u equal x cubed minus 1. Du is going to be 3x squared dx. Well, notice I don't have a 3x squared dx. I have a 4x squared dx I want to get rid of. So to make this a 4x squared dx, I could multiply this side by, I'm going to multiply this side by 4/3. I'll do the same thing over here. So these 3's will cancel. So I'll get 4/3 du is going to be equal to 4x squared dx. So now I can make my substitution. In place of the x cubed minus 1 down at the bottom, I'm going to put u cubed. And in place of 4x squared dx, I'm going to put 4/3 du. This is really 4/3 is really a 1 there. I can move the u cubed up to be u to the minus 3. And now I'm ready to integrate. So this is going to be 4/3 u to the minus 3. If I integrate, I add 1 to get minus 2 and divide by minus 2 plus a constant. So this is going to be negative 2 over 3 u to the minus 2 plus a constant. And now I can plug back in what my binomial was, or my u substitution, and that was x cubed minus 1 to the minus 2 plus a constant. And depending on whether it's a multiple choice or free response, you could stop there, but multiple choice, they might move the x cubed minus 1 down to the bottom and make that square positive. Okay, we can do the same thing for our trig integrands. Okay, so if I wanted to do a u substitution, again, I could let u equal 7x plus 5. du is going to be 7 dx. I just want to get dx by itself, so I divide both sides by 7. So this is going to be the integral of cos u, 1/7 du when I do my integration. And the integration of cos is sine u. I still have the 1/7 out front, plus the constant. So this is going to be 1/7 sine u, and I'll just plug back in right away the 7x plus 5, of course, plus a constant. Now I know back in chapter 5 we did these without u substitution, because in this particular case we could do this one without u substitution. Remember when we took the integral of cos, we said the integral was sine, leave the function inside alone, and then I divided by the derivative of the function, which was 7. So we would get the same answer. Sometimes if this derivative here is more than a constant, then we have to use u substitution and able to integrate. Okay, if we take a look at this one here, okay, again, if you move cos squared up to the top, you're going to get secant squared 2x, and the integral of secant squared is tangent. But again, I'm going to let u equal 2x, and du is 2 dx. I just have a dx there, so I have to divide both sides by 2 to get dx by itself. So now I can integrate. So this is going to be secant, in place of 2x, I'm putting u, and in place of dx, put in the 1/2 du. So this is going to be 1/2. The integral of that is going to be tangent u plus a constant. So it's going to be 1/2 tangent of 2x plus a constant. And that would be your final answer. Okay, in this particular case, remember, this is really sine x to the 4th cos x dx. So again, I'm going to let u equal sine x. du is going to be cos x dx, and that's what I have right here. So in place of sine x, I'm putting u, and that's to the 4th. And in place of cos x dx, I'm putting du. And now I can integrate. So this is u to the 5 over 5 plus a constant. So sine x over to the 5th over 5 plus a constant. That would be your final answer. Okay, this is a multiple choice question. Again, notice they did not tell you to use U substitution, but when you have a product of two functions within an integral, for AP anyhow, the only strategy you have is U substitution. So we're going to let u equal x cubed. du is going to be 3x squared dx, but you only have an x squared dx, so we have to divide by 3. So now we can make our substitution. This is going to be cos, and in place of x cubed, you're putting u. And in place of the x squared dx, you're putting 1/3 du. The integral of cos is sine u plus a constant, 1/3 sine, and in place of u, it's x cubed plus a constant. And so my answer for this particular one is going to be right here, question answer B. All right, this one here, I want you to pause the video and give this one a try. Okay, hopefully you've had a chance to try this. So again, I'm hoping you're getting these now. We're going to let u equal x squared. So du is 2x dx. Again, I just have an x dx, so I have to divide by 2. So this is going to become, in place of x dx, I'm putting 1/2 du. And in place of x squared minus 4, I'm putting u. So this is really the same thing as 1/2 1 over u du. And again, the integral of 1 over u is that special case. It's ln absolute u plus a constant. It's 1/2 absolute, or ln absolute x squared minus 4 plus a constant. And so my answer again is C. Okay, sometimes we can use U substitution for definite integrals. So say we're asked to evaluate this definite integral. Again, I'm going to let u equal x squared plus 1. du is going to be 2x dx. Again, I just have an x dx, so I'm going to divide by 2. And now I'm going to make my substitution, but notice I'm not putting the limits of 0 and 1 on. I'm going to just put in place of x squared plus 1, I'm going to put u, and that's going to be to the 5th power. And in place of the x dx, I'm putting in 1/2 du. Now, the reason I didn't bring the limits of 0 and 1, because 0 and 1 are the limits for variable x, and I've switched everything to u. So in order to not have to do that last resubstitution step at the end, I'm going to change my limits for u. So all I do is I take this 0 and plug it in for x here. So I'm going to get 0 plus 1. So the new limit for u is going to be 1. And if I plug 1 in here, 1 squared is 1 plus 1 is 2. So now I can just evaluate this integral like I did back in chapter 5. This 1/2 is a constant. We'll leave them up front. This is going to be 2 to the 6th over 6 plus 1 to the, or sorry, minus 1 to the 6th over 6. So I'm going to get 64 over 6 minus 1 over 6, which is going to be 1/2 times 63 over 6, which is going to be 63 over 12. And we can reduce 63 over 12 because 3 goes into 63 21 times, and 3 goes into 12 4 times. So there would be your final answer. So For U substitution with definite integrals, you do the regular U substitution, but if you change your limits, just to evaluate the integral the way you have it here on the right in red, and then just use the limits 1 and 2. Again, to get the new limits, I just plug 0 in for x in my U substitution part, and 1 in for x in my U substitution part. Okay, here's the multiple choice example, and the question is they want us to, or they're given this, sorry, e to the root x over root x dx, and they're telling us to use the substitution let u equal root x, and which of these following is an equal integrand or integral down on the bottom. So we know what the u substitution is, so du is going to be 1/2 root x dx. So I just took the derivative of that and put the radical back in. So notice I have a 1 over root x dx, which is similar to this, except I have to get rid of that 2. So this time I'm going to multiply both sides by 2. So now when I make my substitution, in place of root x, I'm putting e to the u. In place of the 1 over root x dx, I'm putting in 2 du. Now note the limits 1 and 4 are for the limits, or for the variable x. So all I do is I plug 1 in here, and the square root of 1 is 1. I plug 4 in there, the square root is 2. So my final answer is going to be C. Now they didn't ask us to evaluate it, they just wanted to know which of these expressions would be equal to the substitution. Okay, a couple more examples. This one here is a bit of a unique solution. So if I let u equal x plus 1, du is simply going to be 1 dx. And notice I have this x here. Well, I can take this guy here and I could say that x, if I subtract 1 over, u minus 1 is equal to x. So now my integral, in place of x plus 1, I'm putting u to the 10th. And in place of x, I'm putting in u minus 1. And in place of dx, I'm putting du. So now I can distribute that u to the 10th to get u to the 11 minus u to the 10th du. And now I can integrate u to the 11th would be u to the 12 over 12 minus u to the 11 over 11 plus a constant. And now I just resubstitute back in u, which was x plus 1. So it's going to be x plus 1, 12 over 12 minus x plus 1 to the 11 over 11. Oh, sorry, x plus 1 to the 11th over 11 plus a constant. That would be my final answer. Okay, I want you to pause the video and give this one a try. Okay, hopefully you've had a chance to try it. So again, I'm going to let u equal x minus 2. du is going to be dx. Notice I have this extra x here. So from this first expression, x is going to equal u plus 2. So in place of x, I'm putting u plus 2. In place of the x minus 2 under the root, I'm putting just root u. And in place of dx, I'm putting du. So now I can distribute, because this is really u to the 1/2. So u to the 1/2 times u to the first will be u to the 3/2. And u to the 1/2 times 2 will be 2u to the 1/2 du. So now I can integrate. So if I add 1, I get 5/2 divided is going to be 2/5 u to the 5/2. Add 1 to get 3/2. Divide by 3/2 is like timesing by 2/3. And I have a constant. So now all I do is plug in what u is. So it's going to be 2/5 x minus 2 to the 5/2 plus 4/3 x minus 2 to the 3/2 plus a constant. And that would be my final answer. Okay, in our last example, this one is again another multiple choice question from a practice test. Let's looks kind of crazy. It's telling me, first of all, x is greater than 0, and it wants us to find the integral of 1 over x times the definite integral from 1 to x of u over u with respect to x. So I'm going to do this part here first. So I'm going to the integral from 1 to x of du over u. Well, the integral of 1 over u is really ln absolute u going from 1 to x. So this is going to become ln absolute x minus ln1, and ln1 equals 0. So therefore, this is just going to be ln absolute x. And because x is greater than 0, I don't even need the absolute value sign. So this part right here works out to be ln x. So my equation now is going to be the integral of 1 over x times ln x dx. So now I'm going to let u equal ln x. Du is 1 over x dx, which I have right here. So now I can use my substitution. So in place of ln x, I'm putting u. And in place of 1 over x dx, I'm putting du. So if I integrate this, this is u squared over 2 plus a constant. And substitute back in, so I get ln x squared over 2 plus a constant. And that should be my final answer right there, which is E. So a bit of a tricky question, but if we take it bit by bit and part by part, it works out quite nicely. Okay, there is your assignment. So some of those questions come from the book, some from the AP text, but there's plenty to try in regards to U substitution.